What is up, guys? This is somebody on YouTube, and today I'm gonna talk about question 1696 on LeetCode. Okay, so the question is you have know already, and I'm not gonna spend time doing that. Okay, the way to solve this question is we need to maintain a DP array, a integer array. Let's call it DP, and what it does is to store the best score at I, right? And at the end, we can just return DP and -1 as our result, right? That's what DP does. Okay, and we will need to use another Deque data structure, right? What a Deque is basically a space where we keep. So whenever so the Deque is to keep track of all the options we have. So according to our constraints, the Deque is at most length k, right? And it also needs to be within the range, right? It also needs to be within the range here, inclusive, and also we're trying to keep track of the maximum score, right? So any score that is lower, we will need to get rid of. Okay, so how do we maintain this Deque? So we will need to, okay, so because we're populating the Deque from this end, so whenever, so that means the oldest element is gonna be on the left, and then on the right is going to be the new elements. So each time we'll need to remove, so first step, remove old options. And the second step is, okay, so this is from the start, right? Because that's where the old elements are located. Okay, the second step is we need to remove bad options. Bad options. What is bad? That means it is, how do we define bad? That means it is less than our current option. Right, and then it's from the end. Okay, that is our algorithm. And this will guarantee that whatever is in front of the Deque, the first element inside the Deque, is the optimal solution for our current step. Okay, so now all we need to do is to iterate through the numbers array and calculate the best option at a current step and update the Deque to maintain these two rules that we just talked about, right? All right. All right, let me just code it up. Okay, so let me code this up. So we know first we need to use a DP array, right? Is equal to new int array, and the length is n, right? Is equal to nums.length, and here's n, right? And we know on the first step it is num0, right? No questions asked. And then we need to use a Deque to keep track of the options, right? Right. And what is the first option we have? That is, okay, here, in index form, right? So this is in it is easier to calculate the age of a certain element, right, compared to, because we're going to iterate through, so it is easier to compare the index to our current index, so we can calculate the age. That way we know which element to get rid of. Okay, so now we'll need to, now we'll need to iterate through the entire nums array, and then at each step we'll calculate the cost and store it to the DP, right? So there will be the sum, the nums I plus whatever is in the whatever is the best option that we stored inside the DP, right? So it will be DP and then Deque dot peak first, right? And then we'll need to check while not Deque dot is empty, and our the age of the element, so it will be the age of element, which is the index of it, minus, or in another way is plus k, is within my I index range, meaning it's it's outside of my index range, meaning it's too old. All we need to do is Deque dot pull first, right? We'll need to remove this element, and also while my Deque is not empty, like we said, and this element is not our best option anymore, so that means my DPI is greater than my current option, the old option, so it will be my DP the peak last, right, because it's in the end, and that way we'll need to remove those. And last but not least, we'll need to add the current option, which is my I into the Deque for our next iteration to use. And then at the end, we'll just need to return my DP array and -1. All right. Okay, so let's do some debugging. So my Deque.peak first plus k needs to be less than I, and also okay, so it's greater than or equal to. It's equal here too. Okay, here we go. Right, because if our current calculation and the previous calculation is the same, we need to remove it because it is old. And then this is because if it's less than I, meaning that cannot reach or just reach I, that means we need to discard it because it is too old, right? And that should work. All right, perfect. Let me see if what happens if we get rid of this. Oh, is it still gonna work? Okay, cool. So this doesn't matter because eventually in the next iteration, in this first while loop, we'll need to remove it anyways because it becomes old. All right, that's about it. Thank you. Question, the space complexity is O of, let's see, we use a DP array and that is size n, and also we use a Deque, right? This Deque has at most k element in it because if it is too old, we'll remove them, right? So there's at most k element in it, so the space is O of n plus k, and the time complexity, it is O of, let's say, we use a for loop, so that is n already, and inside these while loops, we're basically editing the Deque, right? So the Deque is at most k elements, and we can delete them all and add a new one, and we can do that for each element. And actually each element can be only added once, right? And they can be removed at most once, so that is another n. So n plus n is still O of n, right? So that's the space and time complexity.